right, so set theory. So unit number one. We're gonna start out with something called set theory. Okay, this first unit is not gonna seem like math to you guys for the first bit here. It's kind of weird. It actually has to do with well, it's used quite often in like computer programming, and like this kind of like thinking. It's like almost like a different language that we're gonna have to learn at the beginning here. It's kind of strange. It's gonna be different than what you're used to. So the way I've set your guys' notes up, I've got pretty much everything we need like on the left, but the way I've done it for you guys, I've kind of like left you some space on the side there. That's if you guys want to be writing anything that like I'm adding or anything that's going to help you remember, that just jot that down on the side, right? But I do kind of have it set up where everything's kind of there. So if you want to refer back to these notes when you're doing your homework to remind yourself what a set is, or some of these other examples, just go back to the notes. You guys can see that they're not that thick, right? This is the whole first unit, and I've tried to make it as thin as I could. So, okay. All right, so sets. So what a set is it's really just a group of items, right? So when we say a set of something, we just mean a group. So there could be, like in this classroom, there could be the set of students, right? And that would be all of you. And within that set, you could also say there was a set of boys and there was a set of girls. So there's like lots of different ways we can do that. But that's really it. So a set is just a collection of distinct objects, and those objects are called elements. So all the people in the classroom would be called elements of that set. Okay? There's a lot of terms that we're going to go through here, so we just got to get those. This is lesson number one. We're just kind of figuring out all these different terms. Okay. The way we define a set is by using curly braces. And what those are, so curly braces are going to be something like this. So we could say the set of, so I'll put C for all the students in the classroom. You'd start your curly brackets. So this is going to take a while. That was bad, but figuring out how to draw those curly braces kind of is tough sometimes. And then you actually could just start writing like all the names, right? So you just write all of the names in that set, and then you'd close it with curly braces again. Okay, and there's some examples below, so I'm not going to actually like write it. They'll take time to write all the names. But so for example here, example number one says, some examples of sets defined by describing content. So that could be the set of all even numbers, right? That would be all even numbers could be the one set. The set of all books written about travel to Chile, right? That could be a set, right? So an example would be something like this, right? That's how you would write a set, or it could be with words too. So it could be like numbers, it could be words, just anything in that set. Okay. It doesn't matter in the order when you put things in a set. So it could be like 1, 2, 3, or it could be 3, 1, 2. It doesn't matter. Just all those elements are in that set like that, right? Okay. So some of the notation. So we use a symbol. Well, actually, you guys have seen that symbol before. Do you guys know where we use that symbol? Again, 30 or 20-2. It looks like that. Yeah, that's okay. If we were doing domain, right? Sometimes we were saying like, x is greater than 3, and then I put a comma and said where x is a member of the real numbers. That's still the same symbol, and actually it comes from the same thing. When we wrote that out, that was like another way of like writing a set out, right? But that symbol there means is a member of, and that's going to be the same thing here. So the symbol E means is an element of, or a member of. I'll show you what that looks like when we're actually using it a little bit lower. If we had a set that had nothing in it, so maybe that could be like in this classroom, all of the people who are over 50, right? That's called an empty set because there's nobody in that set. Okay, and the way you can write that is just curly braces, and then you just got nothing in it, right? There's just actually no elements in that thing. Or another common way to write that is a circle with a dash through it. Okay, on your guys' formula sheet too, you guys will see there's a section there that looks like this. So you don't even have to memorize a lot of these things. It'll show you, right? So an empty set, and it'll show you what that symbol actually looks like. It doesn't show you this one though, and this gets used. This can be used too. So you also need to know that if there's nothing in it, that's also considered an empty set. Okay. So, yeah.
That's not inner notes, the ones on the right side.
Yeah, they're not. This part here is on your formula sheet, though. I just kind of wrote that there to kind of show you what it would look like when you're looking at your formula sheet. Yeah. So you just have a section on your formula sheet that looks just like that. Okay. So, like in this example, it says let A equal, and it says what the set is for A, right? So to notate that 2 is an element of the set, we could write, and it could look like this. You could say 2 is a member of A. And all we're really saying there is that 2 is in that set. 2 is a member of or is an element of the set A. Okay? All right, subsets. So this is probably a little bit more complicated than it needs to be because I've distinguished this one between a subset and a proper subset. In Math 30-2, we pretty much just think about just subsets. So it's going to be a little easier than what I explain here in a second. But what a subset is if I had, let's say, A is equal to, let's say, 3, 4, and 5, right? So that's what set A is equal to. And then I said B is equal to 4 and 5. Then what we can say is that B is a subset of A. It just means that all of the elements in B are also in A. It's like it's inside of A, right? Everything that's in B is also in A. Yeah? We're going to get like talking about this with like concentric circles and like Venn diagrams and stuff in the next lesson. But for now, we're just kind of looking at it this way. So B is a part of A. So now a subset, it's kind of like when we look at this, it says B is a subset of A. And it's almost like it's less than or equal to, like that symbol is kind of similar, right? So that's what a subset means. It could like B, it would also, you could say B is also a subset of A if it was technically the same thing, right? If it was like the same thing itself, so you could say that's a subset. A proper subset just means it's also not exactly the same. A proper subset means that it's like 4 and 5, but not 3, 4, and 5. It's not also the original set. So it's like I said, the symbol here is like less than or equal to, and this one's just like just less than, if you want it for comparing it. But like I said, for the most part, that distinction between subset and proper subset, we don't even have to really worry about in 30-2. If one of the groups fits into the other group, then it's a subset of that group or of that set. Yeah. Okay.
Does it have to be 2 numbers or just?
It could be any. Like you could have like a whole. It could be just one too. If it was just but all of them would be in here. So like in this case, if I had 4, 5, and 6, well then B is not a subset of A because it doesn't completely fit inside of A, right? It's not completely part of it. So the way we write that, you can see here too, right? Is you'd say B, and then it's like a sideways U, and then A. So B is a subset of A, and I kind of think about it this way, where it's almost like an arrow where this one's pointing to the subset, right? So B is a subset of A, or B is like less than A. It's almost like that too, right? And again, this is on your formula sheet, right? So you guys don't have this in your notes, but in your formula sheet, it shows that symbol too, so you don't have to memorize that one either. Okay? All right. So if we consider these 3 sets, we've got A is equal to the set of all even numbers. So all even numbers you can think of. And B is just these 3 numbers, and C are these 4 numbers. Then here we can say B is a subset of A since every element of B, right, 2, 4, and 6, is also an even number, right? So B is a subset of all of the even numbers. So more formally, we could say B is a subset of A since if X is a member of B, then X is a member of A. That just means if the number is a member of B, then the number is also an element of A. I don't know if that sounded confusing, but yeah, it's a little bit tougher with that X as an element of part. But okay, moving on. And even though I don't go through some of these sometimes, guys, they're just like more examples. So it's for you, right? When you guys are doing your homework questions, you can look through those, and if you see kind of an example that's like these examples, then you can go back and use it. So, okay. Union, intersection, and complement. So again, I just want you guys to know this over on your formula sheet. You guys have these symbols as well. Okay, so you don't have to memorize these as we go through it. But the union, okay, the union of two sets contains all of the elements contained in either set or both sets. Okay, so what did that mean? So that means if I had, well, here, you know what? I'll do it with this example. So we'll just do that one first. I'll do union, and then we'll go to complement and intersection after. So this one says, consider the sets. We've got A, B, and C, and these ones are just dealing with the words, right? It says find A, and then the symbol for union is like a U. That's typically how I remember union, is that it looks like a U. So what? Find A union B. So union means like it doesn't matter which one it's in. It's like or. It can be in this one or this one. So A is red, green, and blue, and B is red, yellow, and orange. That just means I have to have like all of those colors, right? So the union would just be like making sure I have everything in that. Okay? So I gotta make sure I have red, green, blue, right, from A, and then also yellow, orange. Red showed up in both. That doesn't mean I write it 2 times, right? I just write it once. Okay. Now, intersection. So intersection is kind of, what do you guys think it would be? So if it was like A intersection B, what would I be looking for then between the 2 sets? It's kind of in the name, yeah. Yeah, like the one that's similar, right? So that's going to be only where they overlap, right? Only where they cross. So A intersection B. So what do you think without looking at your notes? Red. Yeah, I kind of showed that already, right? Red's the one that intersects. They both have red. So A intersection B would just be the element red. Okay? All right. Complement. So complement, so it's written there too, and complement is written with a little dash. So you got like a little dash on the top. Oh, sorry. So yeah, look down here. So you got a little dash there. You'll see it written that way. It's a weird one too, because sometimes you'll see it as A with a little C on top, and sometimes you'll see it little squiggly line A, and actually sometimes you'll see it like this, where it'll be A and then a line over top. There's lots of ways to see it. Pretty much if you see anything over top of it of any kind, it means complement. We can pretty much just go with that. Okay? So complement, what that is it's whenever I see something like this where it says maybe like A complement, it means everything but A. So the complement of A just means like if I like anything else other than A. Does that make sense? Okay, we'll do more examples of that as we go. But so for this one now, it says find the complement of A intersecting with C. Okay, so this just requires that we just do like one thing at a time. So let's figure out what is the complement of A. So it says here we're looking for all the elements that are not in set A and also in set C. Okay, so not in set A. So if I'm looking at A, it means I can't have red, green, and blue. Right? So I don't want those. It's everything but those, right? But it's also only the things that intersect with C. So I'm looking at C. Okay, so here's C, right? So it's that, but I can't have red, green, and blue. So all the things I can have are orange, yellow, and purple. Yeah, okay. Universal set. So universal set, it'll just quite often at the beginning of a question, it'll tell you the universal set is, right? So it'll say, suppose the universal set is all whole numbers from 1 to 9. It'll say something like that, right? So it's just giving you like the basis for it. So like when I said the set is all the students in the classroom, that's me kind of setting what the limits are, right? Because if I just said, you know, what is the comp, it just kind of bounds it, right? So we know what we're talking about, right? So that's going to be our universal set. So yeah, so like in 7 here, it says, suppose the universal set, and quite often it's written as U, but it could be anything, whatever they tell you, but quite often it'll be U. So universal set is U, all whole numbers from 1 to 9. So then if A is 1 to 4, then the complement of A is always relating to the universal set, right? So the complement is always related to the universal set. So if A is 1, 2, 3, then A prime is everything else in that universal set, right? If you didn't describe the universal set first, then A prime would be every other number in the universe other than those two, right? So the universal set is us actually like bounding it, as us giving some sort of guideline as to what we're talking about there. Okay. You know what? I think we're gonna end it there. So I'm gonna keep it short.